Welcome to Study Loop.
Hello friends, in this problem it is given an ideal vapor compression cycle for refrigeration used to keep space at low temperature. We have to find the cooling rate B part, coefficient of performance C, exergy destruction of each component total exergy destruction of the cycle and second law efficiency. The fluid used is R134. So the properties of R134 using tables A11 to A13. First, temperature T1 is given minus 10 degrees Celsius. Fluid quality is 1, that is completely in vapor state. Enthalpy 244.55 kilojoule per kg and entropy in this state 0.9378 kilojoule per kg per Kelvin. Pressure P2, saturated pressure at the rate of 57.9 degrees Celsius. So it is 1600 kilopascal. S2 is equal to S1 and enthalpy is 287.89 kilojoule per kg. Pressure P3 1600 kilopascal. Fluid property, quality of fluid is 0, so it is in saturated liquid. S3 is 135.96 kilojoule per kg and entropy of the state is 0.4792 kilojoule per kg per Kelvin. Here H4 to V is equal to H3, that is 135.96 kilojoule per kg. T4 is minus 10 degrees Celsius. H4 is 135.96 kilojoule per kg. So S4 entropy in the state 4 you will get from the table 0.5252 kilojoule per kg per Kelvin. Heat absorbed at low temperature H1 minus H4 244.55 minus 135.96, that is 108.6 kilojoule per kg. Answer of part A. Now, heat transfer to the hot junction at high temperature H2 minus H3 287.89 minus 135.96, that is 151.9 kilojoule per kg. Work input will be H2 minus H1, so 287.89 minus 244.55, so it is to be 43.34 kilojoule per kg. Now coefficient of performance, heat transferred at cold junction, heat absorbed from the cold junction upon power input 108.6 upon 43.34, so it is to be 2.506. This is the answer of B part. Now, exergy destruction of each component. First, we will calculate for compressor. So, entropy generation in the process 1 to 2, S2 minus S1, that is 0. So, exergy destruction of compressor is 0. For condenser, entropy generation in the process 2 to 3, S3 minus S2 plus heat transferred to hot junction divided by its temperature. So we will get 0.4792 minus 0.9378 plus 151.9 upon 298. So entropy generation you will get 0.05125 kilojoule per kg per Kelvin. So exergy destruction of condenser S3 minus S2 plus amount of the heat transferred to at high temperature to its temperature, you will get 0.47. For condenser, it is defined as, so exergy destruction you will get, just a moment, that I have to correct. I'm extremely sorry for it. I have to make a correction. T naught into entropy generation in the process 3 to 4. Sorry, 2 to 3. 298 into 0.05125. So it is to be 15.27 kilojoule per kg. Now, in case of expansion valve, entropy generation in the process 3 to 4, S4 minus S3, 0.52, 52 minus 0.4792. So entropy generation from 3 to 4 we will get 0.04595 kilojoule per kg per Kelvin. So exergy destruction of expansion valve T naught into entropy generation for the process 3 to 4, that is 298 into 0.04595. So it is to be 13.69 kilojoule per kg. For evaporator, entropy generation in the process 4 to 1, S1 minus S4 minus heat transferred at low temperature upon temperature of low junction 0.9378 minus 0.5252 minus 108.6 divided by 278. So it is to be 0.02202 kilojoule per kg per Kelvin. Hence, exergy destruction of evaporator to be 298 into 0.02202. So it is 6.56 kilojoule per kg. Now exergy total. Exergy destruction of condensation, compressor, evaporator and expansion valve. Substitute the all values. We will get 0, 15.27, 13.69. So it is to be 35.52 kilojoule per kg. The exergy of heat transfer from low temperature medium EXQL to be minus QL into 1 minus ambient temperature upon low temperature 108.6 into 1 minus 298 upon 278. So it is to be 7.813 kilojoule per kg. So second law efficiency is defined as exergy of heat transfer at low temperature upon power input, work done input 7.813 upon 43.34, that is 0.18 or 18%. Now efficiency of the total energy destruction in cycle total exergy destruction in cycle work input minus exergy at low temperature. So 43.34 minus 35.53, sorry 7.813. So it is to be, which is same as calculated earlier. Now second law efficiency of compression. Power of recovered upon power of actual in mass flow rate into S2 minus H1 minus T naught S2 minus S1 upon mass flow rate S2 minus H1. Since the compression through compressor is asentropic, that is S2 is equal to S1. So second law efficiency of compressor to be 1. that is 100%. Second law, efficiency of evaporator, rate of exergy recovered, rate of exergy expended, that is rate of flow of heat at low temperature upon mass flow rate H4 minus H1 T naught S4 minus S1, which can be also written as exergy destruction in the process 4 to 1 upon exergy rate of exergy at 4 minus rate of exergy in process 1. Exergy in the process 4 to 1 will be H4 minus H1 minus T naught S4 minus S1. Substitute the value 135.96 minus 244.5 minus 298 into S4 is given 0.5252 minus 0.9378. So it is to be 14.37 kilojoule per kg. So second law, efficiency of evaporator, you will get 1 minus 6.56 upon 14.37, that is 0.544, that is 54.4%. That's all. Thanks for watching it.